Good afternoon, everyone. In this presentation, we will discuss the Klang River and how we can improve the water quality for the citizens living in this area by building a new wastewater treatment plant. We will also cover the reasons why old wastewater treatment plants are not working effectively, showcase the design of our wastewater treatment plant and our water filter design, and discuss the challenges we faced during this project and how we overcame them. Starting off, the old wastewater treatment plant has not been fulfilling its purpose because the equipment is getting old and rusted and not functioning properly. The Klang River in Malaysia is considered one of the top 50 most polluted rivers in the world due to the numerous industries in the area that release harmful substances into it. Now I'm going to present the overall project aims and deliverables. In this project, we have to find the unit operations based on the preliminary, primary, secondary, and tertiary treatment stages. We have also created a block flow diagram to show the entire treatment process of the plant. Additionally, we calculated the mass flow rate of each pollutant in the filtration system and designed a prototype of the filter. In Part 1, we focused on the background of the design, such as factors, impacts, and criteria, and identified the main units represented in the block flow diagram. In Part 2, we focused on the drawings, material balance calculations, specifications, and risk management. Finally, we created a prototype to demonstrate our design. Here is our block flow diagram. The wastewater first goes through preliminary treatment to remove large debris using bar screens, comminators, grit chambers, and landfills. Then, the wastewater undergoes primary and secondary treatment, where pollutants like sludge are removed to an aerobic digester before flowing into the river. In tertiary treatment, the water is separated into two parts. The upper part is treated for drinking water through disinfection, while the remaining water is released back into the river. This slide outlines the stages of wastewater treatment. Preliminary treatment involves removing large debris using bar screens, comminators, grit chambers, and landfills. Primary treatment uses primary clarifiers and aeration tanks to settle and remove suspended solids. Secondary treatment further degrades organic matter with aeration tanks and secondary clarifiers. Tertiary treatment includes chlorination and ultraviolet (UV) radiation to disinfect and polish the water, ensuring it meets quality standards before release. Next, I'll discuss how we overcame the challenges of our basic design proposal. We faced two major challenges: determining the location for our wastewater treatment plant and drawing a block flow diagram. We solved the first problem by researching polluted waters in Malaysia, which led us to the Klang River Valley area. To tackle the second problem, we used a step-by-step approach to complete the block flow diagram. Moving on, these are the views of the proposed wastewater treatment plant. The side and top views illustrate the layout and dimensions of the plant. Here are the side view of the wastewater treatment plant. Here is the top view of the wastewater treatment plant. Increasing the number of wastewater treatment plants will help improve the economy by providing clean water for agriculture, which can generate income for farmers. It will also create more job opportunities for local citizens. During this project, we learned to work more effectively as a team, communicate better, and provide constructive feedback. We hope to complete some tasks more efficiently before meetings. Moving on, I will be presenting the design of our team's filtration unit. There have been many challenges that we have encountered as a team while working on this part of the project. One of those challenges is the lack of experience and the knowledge of our team in the implementation of drawing software such as AutoCAD and SketchUp into the proposed design of our team's water filter. This has forced us to be versatile in order to solve the problem on hand by learning the required software online using platforms such as YouTube and whatnot. The lesson learned during this stage of the project would be that we have to learn how to be adaptable when encountering difficult situations in order to overcome an obstacle. The things that I would have done differently would be to delegate more tasks to my other team member and emphasize that the task must be completed beforehand. Next, we will move on to the drawing of the water filter. As shown here in the slide, this is the isometric view of the water filter designed by our team. The drawing of our team's water filter is drawn using SketchUp. Moving on to the next slide, we have the side view of the water filter. As you can see in the slide, the dimensions of our water filter are labeled in the unit of centimeters. The total height of the water filter would be 48 centimeters. The width of the water filter would be approximately around 10 centimeters. The material used to build the outline and the structure of the water filter would be recycled plastic. The methods of construction for this water filter would be 3D printing. This is in line with the Sustainable Development Goal, SDG, that has been emphasized time and time again in this project. This diagram illustrates the contents of our water filter system. It includes layers of small rocks, big gravel rocks, crushed charcoal, small gravel, sand, and finally cotton balls and ultraviolet radiation. Clean water comes out at the end of the filtration process. Here, you can see the top and bottom views of the water filtration system. The left-hand side shows the bottom view, and the right-hand side shows the top view. The bottom diameter is 10 centimeters with an inner circle diameter of 6 centimeters, and the small holes have a diameter of 1 centimeter. The cap in the top view is 5 centimeters long with holes in between measuring 4.6 centimeters. We faced challenges in coordinating team meetings to discuss the project. We overcame this by using WhatsApp to communicate more frequently about our availability. This helped us communicate effectively and consider each team member's viewpoint when making decisions. Additionally, we learned to delegate tasks efficiently to complete the project. In conclusion, the Klang River is highly polluted, and our wastewater treatment plant aims to improve water quality to benefit citizens' health and other needs. Lastly, we will introduce our prototype by showing you a video.
Hi there, you are watching the ENG1002 project prototype video. This is group 14. So before we start the testing of the water filter, I would like to quickly show you the contaminated solutions we have decided in order to use in the test. So this is the contaminated solutions. It contains the cooking oil, food scrap, microplastic, leaves, slate, and fruit coloring, which are the same substance that we have written in our report. Now I'm going to show you our water filter and also the filtering material. In this filter, we use 6 types of filtering material, which are the small rock at the first layer, and then the big gravel underneath, and then the charcoal, and then the small gravel and sand, and then the cotton in the last layer. So now I would like to pour the solutions into the water filter.
I see.
Okay, as a result, we can see that the water is come out after the filtrations. Even though the water is not clean enough, but most of the substance have been filtered successfully. So that's all for this video. Thanks for watching.